Hi everyone, this is Asim here. Welcome back to our channel. So in this fourth episode of Be the Hacker series, we are going to talk about some basic cryptography. After we have learned about that, we would move on to the missions. So in this starting part where I explain the basic cryptography, we would start with ancient cryptography methods, and then we would move on to talk about some advanced cryptography. We won't delve into the mathematics part of that, but just how it goes. Then we would talk about some of the misunderstood terms like difference between encryption and encoding, steganography and cryptography. Then we would move on to hashing and how you could create your own hashes, and talk about some hash collision attacks and how SHA-1 was recently shown to be broken practically by Google and CWI team. Then we would see how you could verify the integrity of a file that you have downloaded from the internet by using hashes, and that could help you to verify that whether there has been any tampering done with that, or whether there have been any man in the middle attack performed on that. So then we would see how modern cryptography helps in securing connections. Even this connection, the very connection you are watching this YouTube video on, it's being secured due to the modern cryptography. So we would wrap the slides by discussing a major crypto fail in the last century. That was the breaking of Enigma by allies. So, and eventually that led them to win the war, the World War II. In coming to the mission part, so in the mission we would start with understanding how the crypto scheme there works, and we would try to manually break that. In the process we would learn about ASCII coding and some other encoding schemes. Then we would wrap the whole session by a 5-liner Python code which would help automate the whole thing that we have done manually. So need not worry, it's not a very difficult thing, and I would try with the best of my abilities to explain that. So let me know in the comment section how that goes. So that's all the intro that I had. Now let's move on with the session. So let's start with cryptography. So the first question that comes to mind is, what is cryptography? So it's the practice and study of techniques for secure communication in the presence of third parties, and these third parties are usually called as adversaries. So it's not a very new thing. Cryptography has been practiced since long time immemorial. So it's important to know about ancient cryptography as well, because even in the missions, and you could see how it has been evolved, and in the missions as well it has been shown how simple cryptography is very easy to break using normal pen and paper tools. So no complex mathematics involved in that. So in the first cipher we see that it's basically a transpose cipher, rather shift cipher, where the offset is -3 in this case. However, the offset could be varied, and that was the basic key that should be kept hidden. In the second thing, where we see how Spartans were using, so there used to be a fixed length block which had a fixed diameter and the fixed number of edges, suppose 8 edges or 10 edges. And when you wrap the parchment of the secret encoded message, so if you had the similar size of block of stick, or with the similar number of edges, you would actually get the decrypted message. Otherwise you won't get the message. Like if you had 6 edges instead of 8, so you would get a totally different message. That's how rudimentary the methods used to be. But nowadays a lot of maths is involved in modern cryptography. As you could see in the diagram itself, the Diffie-Hellman key exchange algorithm. So here two parties, Alice and Bob, are trying to exchange messages, and a lot of maths is involved so that the secret key is transferred secretly. So do I have to be a math genius? No, not at all. Like, you are using computers daily, but you don't need to be a hardware or software genius to do that, right? I agree, modern cryptography involves a lot of high-level mathematics. These are courses that are usually taught in colleges, but the basic terminologies are important, so let's focus on those. So plain text, ciphertext and key. These are terms you would get to see every now and then if you are reading about cryptography. So plain text is any unencrypted message, the messages which you want actually to be delivered. Ciphertext is the message that's the encrypted one, and key is the password or the passphrase that's being used to convert plain text to ciphertext. So this is a pictorial representation of that, where Alice and Bob are the two parties who want to transmit data securely without Eve trying to eavesdrop on that. So what Alice does is she uses her key to encrypt the message, and Bob on the other end uses the key to decrypt the message. So even though Eve can see the message, but all that she would see is gibberish text which she cannot make a meaning of. So there's a frequent confusion among people when they are starting or when they don't have a lot of knowledge about cryptography. So the three key differences that I want to make sure before we proceed are encoding and encryption, steganography and cryptography, hash and encrypted text. So first, encoding. So encoding is basically meant for data usability. So as we saw in the invite spoofing attack in the last episode, as how Google was encoding the data because the data contained double quotes and similar kind of things, spaces and all that, which was difficult to transmit on the media, the HTTP media. So encoding was done. There is no key involved in that, and it's like it doesn't involve any secrecy. So encoding shouldn't ever be used to transmit any secret data. So just an example, if I show you base 64 decoding, if I open AES in decryption method as well. So suppose I write hello world here, hello world exclamation. So this is encoded in this, but anyone who has this method, it could easily decode it using online tools as well as in the browser itself. However, if I try the same here and I write, if I write this hello world, I need to have a key because without key you cannot like encrypt that. So let's add a 16-bit key because that's what is required here. So if I encrypt this, so this is the output that's there. So I try to decrypt it and I need to have the exact same key before I can decrypt it. Like if I change this to 7, it won't get decrypted. So changing back and see if we could decrypt. So plain text. So here it's that. So that's encoding versus encryption. Coming on to the second one, steganography versus cryptography. So steganography is basically hiding messages or data. So hiding could be done in images as well as MP4 files or in movie files. So we have seen that steganography doesn't require key. It's not necessary to have a key, but it could be used either way. So you could do things like you could encrypt a message with cryptography and then add steganography to add a layer of stealth to it. So usually images, MP4 files, these are used to send steganography, to do steganography. Coming to a third one, hashing versus encryption. So hashing is basically used for verifying the truthfulness of the data or the integrity of the data. So hashes are basically any large file or any large blob of data is converted to a fixed string so that you could match it and verify that the file's integrity is being maintained. Like MD5 sum is one of the popular hashing methods. So let me show you that. So if I do echo hello world and I pass it to MD5. So this is a terminal where I'm passing the MD5 sum. This is a function which creates a MD5 hash. And this is the fixed length hash. So hello world has a fixed length hash of this. So if I make the hash online as well, so it would have the same thing. It would generate the same hash. Even if you change a single bit of it, like you cannot recreate the same hash. Hello world. So you would see that the hash is different, right? So it's because there is a new line character added to it. So if I do a echo hyphen and I remove the new line character, and if I then compare this, so it's the same hash. Or if you want that I produce this same hash, so you would have to add a new line here. So if you now copy this and compare it with here, you would say the same hash. So basically you could verify that hello world has been tampered. So if tampering here means even if you added a new line itself, so the hash changed totally. As you could see, it changed totally. Another thing about hashes is that you cannot restore the actual value. Hashes could be used to verify the integrity of TBs of file, like GBs of file, TB of file. Like the file size could be 1 TB and you could create a hash of 32 characters of that, and that could be verified and that could be used to verify the integrity. Like if the file is transferred over a wire and some malicious actor modified it on the fly, so the person who has received the file, he could ask the owner to send a hash on a secure channel, and then he or she could verify the integrity of the file by comparing the hash. So these algorithms are public. MD5 hash and SHA-1, SHA-512, these are public, and these are available on all systems, or you could even use online systems to generate hash. So anyone could generate a hash and check the integrity of that. So surmising all those things, so encoding is used for data usability, encryption is used for data confidentiality, hashing is used to check the data integrity. So common hashing techniques, as I showed, MD5, SHA-1, SHA-512. So MD5 is known to have collision attack. As you could expect, it has a very short, like 32 characters. You could easily imagine like everything could not have a unique hash because everything could not be contained in a 32 character string, right? So, and this SHA-1 was recently shown to be like broken in practice, because in 2005 it was shown that it could be broken in theoretical attacks, but there was no practical attack. But in recent times, the Google and CWI, they collaborated to show a practical attack where they created two docs with the same SHA-1 hash. So that should not have been possible. So collision happens because there's a limited character set, and so it was possible, but till now there was no practical impact. But now it has been shown that it could be practically broken. So document signature, the digitally signed documents, the HTTPS certificates, these certificates, as you could see, there's a SHA-1 hash and there's a SHA-256 fingerprint. So these things, these were all usually using SHA-1, so now they are using SHA-256 as well. The SHA-1 hash, which was shown to be broken, now they have moved to SHA-256 as well as SHA-512. So you might ask, Asim, how does cryptography help us solve all these problems? So as you saw, there is a connection secure thing. Even the video that you are watching right now, the YouTube, it's a secure connection. So whatever cookies or password that you have entered while you were trying to log into your Google or Facebook, so those were encrypted using some algorithm, some public key algorithm or private key encryption. So TLS, AES 128-bit, then SHA-256, all these. So you could see this. These are the screenshots from my Mozilla browser. So before 2006, I guess, so even Facebook was using HTTP. Almost a lot of websites were using HTTP. So an attacker who was essentially on the same network could easily sniff your cookies and passwords, so as to get the sensitive credentials as well as your bank account details if the bank was using a HTTP website instead of an HTTPS website. But nowadays you need not worry, because most of the websites are HTTPS, so your connection is secure. So the main question arises is, what if the encryption breaks? Yeah, I mean, a lot of people have tried it and even it was successful, and the major crypto break was the breaking of Enigma, which the Allies did in World War II, and which led them to win the war quite faster. So it's estimated that the war was shortened by as much as 2 years due to Enigma being broken. So Enigma was a crypto machine that was being used by the Nazi Germany. All their messages were encoded using that. So there's a movie, Imitation Game, where it's being shown how Alan Turing, the famous mathematician who played a pivotal role in breaking some of the ciphers and helping British and Allies win the war. So that was one of the famous crypto breaking thing. Enough of the talk. Let's do some of our own crypto breaking. So I've logged into the site. Let's check out the mission. Basic mission 6, I guess. An encryption system has been set up which uses an unknown algorithm to change the text given. Requirements are persistence and some general cryptography knowledge. So I have taught you some kind of cryptography, but we would see how basic cryptography it's using. So you would see that I have already completed this mission. So what happened is I actually recorded the voice, but I forgot to start the screen recorder. So that's why it's showing that I've already completed this level. Nevertheless, we'll do this again. So network security, Sam has encrypted his password. This encryption system is publicly available and can be accessed using this form. So you have recovered this. So we have recovered his encrypted message. So let's see, we have this is the encrypted message. So what I'm gonna try is I would enter a string 000 string, and we'll try to encrypt it and check how the encryption is transforming this plain text into a cipher text. So we see that it's doing a simple transformation, I guess. So what I passed on this and I got this, right? So if we see carefully, it's basically transferring with one location. Like the index is 0, so it's shifting it 0. Its index is 1, it's shifting it to 1. Index is 2, it's shifting as 2. Index is 3, and similar. So what we have to figure out is, we have to figure out a string which when transposed with this, like, let me show you. So we need to find a string that when shifted with 0 characters would give 3, shifted with 1 character would give 3, shifted with 2 characters would give 9. So here we could say that it would be 7, here we could say it would be 2, here we could say it would be 3. Because 3 when shifted with 0 character would again give 3, 2 shifted 1 character forward gives 3, 7 shifted 2 characters forward would give 9. However, we get stuck here. So what you might ask is, Asim, what's going on here? Like, what is the shift of this? Like 1, 2, 3, I guess, and ABCD, I know what shifting that with what we could do. But what about this colon? How do we shift that? Basically, it's not a simple shift. It's shifting using ASCII table. So ASCII table is basically converting these to a number. So let's check this one. So like if you write 3, so the ASCII value of this is 51. And 51 shifted 0 characters backward is 51. 51 shifted 1 character backward is 50. So if we check the ASCII value for colon, it's 58. And what we need is 3 characters backward. So 58 minus 3 is 55. So here it would be 7 again. Similarly for F. So F shifted 4 characters backward would be, so F is 102 minus 4, 98. So it would be B. Then 5 character it would be A. Equal to shifted 6 characters. So equal to is 61. Shifted 6 characters 55. It would be 7. H shifted 7 characters. So H is the 104. Shifted 7 characters. It's 97. It should be A. So this should be the password. So to verify whether we have figured the encryption mechanism is right or not, we could do is we could pass this as the string to encrypt, and we should get this as the answer. So if we get that as the answer, so this is what we got as the answer. Let's verify this. So I've copied that. So, and as you can see, this was the password. So this is the password, and as I told you, I would also show you a method where we could use our Python skills to do this. Much shorter way than what I have shown. So I use IPython, that's a bit nice, but even simple Python would do. So you need to know of 2 basic things. Order. So if we do a ORD, so it would show the ASCII character value of that. So if we go and check A, so A is 97. So we got order 97F, and if we want to convert it back to the character form, so we would do it like this. So CHR is for converting the number to a character, and ORD is for converting a character to a number. So what we need is, this is the encrypted text. Sorry. We need to find the decrypted text. So let's place a variable for that. So we need to loop over this, and we need to figure out. So I'm doing a loop like this so that I could get the index of the values, because I need to subtract the index value from that. So we need to convert so first, let me not write this like this. So first I need to convert the character to its ASCII value. So encryption. So this is converting it to the numeric form. Then I need to subtract the index from itself. Then I need to convert this back to the character form. So I write it into CHR. So now if we do a print dec_t, so we get the same value as that. So you saw how easy this was. So that's pretty much all. So yeah, let's talk about ASCII. So what happens is, since machines understand only binary, so it's important that we convert all these characters, ampersand, colon, equal to, backslash, and all those things to some value. So this contains only 128 characters, and the ASCII table contains another 128. But this is limited to 256 characters, because it's, so 255 it's there because it starts from 0 index. So that's why there's 255. So there are other schemes where, like, because suppose if you want to write Cyrillic characters or Chinese characters, so there are other like character sets which have a larger space that would incorporate all these. So that's all for this. Hope you had a strong learning with this. In the next episode, we would see remote code execution and some quite fancy bounties regarding that. So stay tuned.